Fruit bats are beautiful, beautiful animals. Watching them fly through the air is amazing. They're so graceful. They're amazing in terms of seed dispersal. We are in a rural town in Myanmar. My name is Jen. I'm a veterinarian with the Smithsonian Global Health Program. I've been out here trying to place tracking collars on some of the world's largest flying foxes. Not only are bats known to be carriers of rabies, they're also known to carry a lot of other diseases such as Nipah and Hendra, and a lot of other emerging infectious diseases that we still have not yet identified. Our goal is to be able to find out what diseases in particular are these bats carrying, as well as follow them across their very large migration pathways to see where are these diseases moving across the country and across the globe. Mammals do carry diseases that other mammals can get. That disease is able to cross species and get a human being sick. They're eating from their fruit trees, they're sharing a lot of the produce. It's a lot of direct contact, and that's a perfect setup where you can have a virus that can hop species and become infectious to people. We'll be taking biological samples to screen these bats for different viral diseases that they may be carrying.
My name is John McAvoy and I'm a movement ecologist. GPS collars really have taken things a big step forward in our knowledge. We can know a lot more about their movement and their behavior than we previously did. We're tracking them so we can learn about where they move in relation to humans. Where do these bats, which are important vectors for disease, where do they travel?
We came up with a way to get a collar that can remotely download all of our information. It will track the GPS movements of these animals. It will track the ambient temperature at the time as well to see if they're seeking out particular environments. The collars are designed with a weak link that will break down biologically over time and will fall off. And that way, not only can we follow the movement of the bats, we can follow movement of disease in these populations. This particular site where we're at, the tree is right across the street from a restaurant. There's food carts all over. There's a lot of feral dogs that are running around. So there's a lot of different types of exposure pathways. It's about 3 a.m. We set up everything, and now we have to wait for the bats to come back from their foraging activities, hopefully within the next few hours. They will all be back by daybreak, which should be at about 5:30 a.m. It's just a waiting game at this point. They're just coming in for the morning. They've been out foraging all night, so there's a lot of shuffling about as the bats are trying to get settled into their roosts for the day and making sure that they want to be sharing a branch with who they want to share a branch with. We do want to protect them. They're not a bad animal to have, but at the same token, we just want people to be careful and know how to prevent things from happening. By figuring out where are these diseases coming from, we're able to hopefully stop future outbreaks as well as really help the people that live with these animals to live in a safe way.